Hey guys, we've talked about everything involved in moving information from point A to point B. Now it's time to actually see what's involved in moving the information on the equipment from its simplest point of view. Now the easiest way to be able to do this is going to be on the idea of static routing. Static routing is where we as administrators go in and we do the necessary configuration to ensure that our information can reach its destination. And that's going to be divided into a number of operations. So when we look at how we deploy routing, what we need to understand here is it really understands or boils down to path identification and selection. But I'm going to go so far as to say best path selection, because that's really and truly what our routing protocols are going to do for us. Now, like I said, it's going to evolve the best route, so it's going to be the best path, and we're going to rely on routing to maintain and verify routing information. This distills down to the concept of forwarding packets in our infrastructure. Now, irregardless of how our infrastructure is implemented, if we're going to do it manually using static routes, we're going to have to do the implementations on a case-by-case basis. So in this instance, one of the reasons that we have a dynamic routing protocol is that if we were going to do this manually, on each of these routers that we have in our infrastructure, we would have to touch each one of them in turn, and we have to make certain that we included every possible prefix in our environment to ensure that we had exact reachability information in order to be able to send packets throughout the topology. Now, really and truly, what this boils down to is, like I said, the creation of these routing tables. The routing table encompasses initially, out of the box, any physical interfaces that we have assigned to our devices. Now, I'm stressing that because we're putting IP addresses, and in turn, we're actually assigning networks to our interfaces. And the moment we do that, we begin populating this idea of our routing table. And notice it's going to include destination IP, it's going to include the exit interface, and it's also going to include a next hop address if we need one. And it's going to fall into two different categories. We have connected interfaces, which we're going to get by default, and the capability of learning interfaces, or other networks, not interfaces. And we also have this idea of a static prefix that we can use for reachability. So in other words, what ends up happening is this network has the capability of reaching this network, but we have to take into account the fact that we're going to have the ability to hop between devices in order to reach a destination, which means we're going to have multiple paths. Now, we may not have multiple paths in the routing table because they would have to be, one, have the same administrative, one, have the equal mask length, that would have to be all of the same length, then they would have to be from the same routing protocol, and our metrics would have to be equal in order for us to be able to do this concept of equal cost multi-pathing. But the main thing that we need to understand is when it boils down to static routes, these aren't really that involved, because we're going to have very little that we can do with regard to doing things on a case-by-case basis. So the primary difference here is between static routes and dynamic routes. The biggest point is that static routes are going to be administratively intensive. It's administratively intensive because we're going to have to touch every device, and every time we make a change, we're going to have to touch every device again. The other thing here is the benefit is it does take up less resources as long as we have an environment where we don't have a whole bunch of choices. In those scenarios where we don't want to do administration on every device and we want our changes to be propagated in a dynamic fashion, we need to do dynamic routing protocols. Now, the dynamic exchange of routes takes place by exchanging information and us propagating that value of a learned prefix. Now, a learned prefix is going to show up in our table using the denotation that tells us what protocol we use to learn it, whether it's OSPF, it's BGP, it's EIGRP, or it's RIP. So again, stepping into this and understanding what's going on, keep in mind from a 30,000-foot view that there are fundamental differences between dynamic and static routing. Now, when I want to use static routes, there are going to be special circumstances. Among those, the most frequent scenario is going to be in small networks that only require simple routing. My biggest suggestion for most clients is when I have a single router connected to a switch or a series of switches that are all connected to hosts, and I only really have to worry about getting to the internet. That's going to be more often than not where I'm going to employ a static route. In fact, I'll employ a special kind of static route called a default static route. And we also are going to find situations where this can be deployed where we may be in a hub and spoke topology, where for one router to reach any other router, it must traverse through a single connected hub. Therefore, we have a hub and a spoke topology. Also, this is going to be typifying what we refer to as a star topology, both logical and physical. Now, when do we don't use static routes? We never want to use a static route in a large network, and we never want to use a static route when the network is expected to scale. So in other words, when we want to add density, we want to increase network population, where we want to grow and expand and manipulate our infrastructure, static routes are not the way to go. In fact, it's not just counterintuitive, it's foolish to try to go that route. So the ideal scenario is going to be where we have a stub network. Now, what I mean by stub network is I'm talking about a network that goes nowhere. I'm not transit to reach another destination. And we'll talk about the value of stubs later on when we start talking about EIGRP and OSPF. But in the confines of our current conversations, all I need to worry about is that I have one destination on this network. So looking at this, what I need to recognize here is that this is going to be situationally defined. So notice I have a network, 172.16.10. I may have .1 here, .2 here, .254 here. But when I look at this, all I'm going to say is that if any of these devices in this network, 10.0.0.0 slash whatever, let's just say /8, wants to get to this destination, anything on this network segment, on this router, all I'm going to do is say IP route anything that is destined to 172.16.10, the network. Specify the mask, which is going to, again, solidify the fact that this is the network. It's going to tell it, send it to this hop, which is going to be the actual physical interface of this router. Now that means any information from here is going to be able to make it to there. Now, we have to also look at the fact that our data flows are bidirectional in nature. So we can get information through our infrastructure, but that doesn't necessarily mean that that particular stub network is going to be able to get information back. The other thing that we may want to do is make the determination, like when we're going to be hitting the internet, where we do not have any more specific routes, what we may want to use is a static default route. A static default route says anything that is going to be the least specific match, send out this particular interface. And that's going to be denoted using the IP route, and we can actually use it to send it either to a next hop IP address or out of a physical interface. Keeping in mind, if we send it out of a physical interface, we still have to recurse it such that we can get all of the information associated with it. Excuse me, if we send it to an IP address, we have to recurse it. So we need to know what physical interface to actually send it through. So we can point it to a next hop, or we can point it out an interface. The next part of this is going to be understanding what ends up happening and how to verify reachability. Well, first and foremost, if I want to look at any of these, I can do my show IP route, and I'm going to see my static prefixes denoted by S, and it's going to tell me how it's going to reach it. Now, when we look at this, what's going to happen is the system, the router, is going to create, or it's going to look at the routing table. That's what this is that we're looking at. This is the routing table. And it's going to say, well, if you want to reach 172.16.10/24, I want you to use 17.16.21. Well, what's going to happen is by that concept of recursion that I'm talking about, the system wants to find an interface that it knows that it can switch the packet to. So what it's going to do is it's going to say, well, how do I reach 172.16.21? So it's going to parse the table to where it's going to find 117.16.2, and it's going to say, oh, it goes out serial 000. But once that's done, now what I need to do is I need to be able to resolve my layer 2 concept. In this issue, it could be HDLC, it could be PPP, it could be a frame relay connection. But the main thing that we need to understand here is that we still need to have the layer 2 information so that we can actually take that packet, break it up into frames, and serialize it on our link. Now, stepping into understanding how it happens with regard to verification, other options that we have are going to be doing things like pinging to see if we have actual reachability. And we also want to be able to examine the contents of that routing table that we looked at. Again, we're going to look for a denotion of an S. And if we have a default static route, we're going to look for a denotion of an S with a star, the symbol above the 8. I'm sorry, I'm drawing a blank. An asterisk. So once we see that, what's going to end up happening is that's going to tell us that we actually have a default static route in our infrastructure. Now, if I want to configure it to do it, what I'm going to do is verify that it's been configured. And notice here's what I'm talking about. I have the S with the star, and what we're going to see here is also it's listing it as a default gateway, a gateway of last resort. Where S is static, what's missing here is it'll actually show here, it'll say candidate default. So that means that we have a static prefix in our infrastructure, or actually a static default prefix in our infrastructure. Now, keeping in mind reachability information is extremely important, what I'm going to do is I'm going to throw up a GNS3 session, and we're going to walk through this and walk through the exact idea of being able to set it up so you guys can see it actually work. All right? So I'll see you guys in our virtual lab. All right? That's the end of this lesson. I'll see you there. Bye-bye.